Welcome back. Now we are going to work on problems from section 9.2. A quick summary. Testing mu when sigma is known. This is the sample test statistic. You need x bar minus mu over sigma over square root n. This is because sigma is known. Then conduct the corresponding p-value search. Okay. You find the p-value, be it left, one-tailed, two-tailed, and then if the p-value is less equal level of significance, then reject H naught. If p-value is greater than alpha, then do not reject H naught. Now, when sigma is not known, you would use the sample standard deviation. So now you have the sample test statistic is denoted by T. You are going to use the similar formula as for standardized normal value, but now instead you are using T. Instead of sigma, you are using S. Okay. This comes with a degrees of freedom n minus 1. For this, you would find p-value again using the student's T distribution. If p-value is less equals alpha, then reject H naught. P-value is greater than alpha, do not reject H naught. So notice p-value typically in student's T distribution, p-value will be in an interval. Okay, so you will get a range. So this is a little different than the previous case. All right. Then there is the other approach that is called the traditional method. You are going to, instead of finding p-value, you simply check whether this test statistic falls in the critical region. So what is the critical region when sigma is known? Well, sigma is known. You are looking for find the critical region on the graph of sampling distribution. Okay. Then you use the test statistic and then proceed. Okay. So right now let's try our problems. Problem 1. Golf course designers have become concerned that old courses are becoming obsolete since new technology have given golfers the ability to hit the ball so far. Designers therefore have proposed that new golf courses need to be built, expecting the average golfer can hit the ball more than 250 yards on an average. Now, suppose a random sample of 143 golfers be chosen so that their mean driving distance is 248.3 yards. So that's less than 250. The population standard deviation is 45.7. Use a 5% significance level. Okay. Now, calculate the followings for the hypothesis test, where null hypothesis is mu is 250. Alternative hypothesis is mu less than 250. Why would you choose less than? Because your sample got you less than 250. So that's less than. So this is a left-tailed test. Okay. So you want to find the test statistic. Notice in this case, you are given population standard deviation. You are given population standard deviation. In other words, you know sigma. So this is the formula that you need to use. All right. So I have input all this information here. H naught, mu is 250. H1, mu is less than 250. Number in your sample size, 143, random sample of 143 golfers. The mean for your sample is, okay, the mean of that sample is 248.3. Population standard deviation is sigma. And what is 5%? That is significance level. That's alpha. 5% is 0.05. Now we are going to use this formula to find the sample test statistic. Z equals x bar minus mu over sigma over square root n. X bar 248.3 minus mu 250 over sigma, that's given to you, over square root 143, that is their sample size. There you go, square root 143. So let's find the test statistic. For this, I will need our calculator. So carefully put this. Notice there is a numerator and a denominator. So I'll place empty parentheses for numerator, empty parentheses for denominator. Go inside and start filling. Downstairs is 45.7 divided by square root 143. The numerator is 248.3 minus 250. So that is your statistic. Okay, test statistic. So let's get that input. That is your test statistic. The p-value. P-value is, well, you want Z less than this. Why did I choose less than? Because that is the left-tailed test. So you want Z to be less than this. I will round it up to 2 digits, 4, 4. The one after that is a 4. So I'll just keep it 0.44. All right. Now use your table. Z less than 0.44. Okay. So negative 0.4 and you want the column of 4. There you go. That gets me 0.3300. Okay. That's the column for the second 4 digit and this is the first, right? So 0.3300. Okay. So that's my p-value, 0.3300. Now, is this number, the p-value, less than or equal less equal 0.05? What is this? Level of significance, that's alpha. Is this less equals this? No, right? Because it is not less equals, because the p-value is not less equals 0.05, we cannot reject H sub 0. That is, our study is not statistically significant to reject null hypothesis. There is not sufficient evidence. There is not sufficient evidence to warrant rejection of the claim that the mean driving distance is. So that part is the H naught. We do not have enough evidence to reject H naught. All right.